All right, next we're going to solve equations, this time with decimal coefficients. So the process is going to be somewhat similar uh, as to what we did with fractional coefficients. But I think decimal coefficients will be easier. We won't have to find a least common multiple. So here's an example of a linear equation with decimal coefficients. So we've got a decimal here, a decimal there, and a decimal there. So the coefficients are 0.25, 0.0005, and 2.8. So in order to remove the decimal points, one needs to multiply each coefficient by a power of 10 great enough to move the decimal point to create an integer. All right, so what we'll do is we'll look at each of these decimal numbers individually and note the placeholder of the last digit. I didn't really draw that very well. So the place of the last digit. So here we can see the place of the last digit is in the hundredths place. Here, the place of the last digit is the 10,000ths place. And here, this 8, which is the last digit, is in the tenths place. So between the three decimal coefficients, 0.0005 has the greatest place value of 10 thousandths. So since the greatest place value is 10 thousandths, we will multiply by 10,000. So notice we're going to end up multiplying the entire equation by the same place value, okay, 10,000, 10 thousandths, as the greatest decimal place that we've got in the equation itself. So we're taking this original equation, 0.25x, 0.0005 times x plus 3, and 2.8, and we're just multiplying everything by 10,000. All right. And, if you call back to the decimals section that we learned earlier, remember that you're going to move the decimal point to the right equal to the number of zeros. So 10,000 has 4 zeros. So we're just going to move the decimal point 4 spaces to the right. So we've got 0.25. We're going to move it 4 places to the right. 1, 2, 3, 4. Put a new decimal point and put zeros for placeholders. Okay. And then that's going to be times x. Over here, we've got 0.0005. And now we're multiplying that times 10,000. So we're going to move the decimal place over 1, 2, 3, 4 to there. So that's going to be 5 times x plus 3. And here we've got 2.8. I'm going to put 2.8. And now we're going to move that decimal place 4 spaces to the right. 1, 2, 3, 4 decimal place. And where there's gaps, we're going to put zeros for placeholders. So let's rewrite this before we proceed so that we don't get confused with what we've got. So this first term is going to be 2,500x. This next term is going to be plus 5 times x plus 3. And that's equal to 28,000, like that. All right. Now this is something that looks a little more manageable. So now we can just distribute. So we have 2,500x plus 5x plus 15 is equal to 28,000. So we've got like terms here. So we can add those two together. So we have 2,505x plus 15 equals 28,000. And then subtract 15 from both sides. That goes to 0. And we have 2,505x is equal to 27,985. And then divide both sides by 2,505. That'll cancel. And we're left with x is equal to 27,985 all over 2505. Now we have to see if this can be reduced. So what we need to do is off to the side, we need to do factor trees for 27,985. And so 2 and 3 doesn't work, but 5 does. And we're left with 5597. And then the other prime numbers don't work until you get to 29. And you get 193, which is a prime number. So 27,985 is 5 times 29 times 193. And then we've got 2505. And 3 does divide that. And you get 835. And 5 divides that. And you get 167. And 167 is prime. So we have to stop. So 2505 is 3 times 5 times 167. You'll notice we have a common factor of 5 we can cancel out. So that leaves us with 5,597 divided by 501. And I'm going to leave this as an improper fraction. Okay. All right. So that's how we solve equations with decimal coefficients with a worked out example there. So try this think, pair, share on your own. Okay, this one on this page. This one should come up with an answer of 101,380 all over 599. So give that a try and see if you can do it.